So we're going to look at vertical asymptotes. This is how you spell it. So vertical asymptotes are very similar to finding the domain, and specifically the domain of a rational function. So what I want to do first is just look at an example and refresh ourselves on how to find the domain of a rational function. And let's just say example 1, find the domain. And we'll look at 2 examples of this. The first one, let's call it f of x is equal to x squared minus 8 divided by x minus 3. So, let's refresh ourselves on what domain means. Domain is the set of all the x values that this function exists. So a function does not exist, or is undefined, I should say, when we have a 0 where? In the denominator, on the bottom. We cannot have a 0 on the bottom because that's undefined. So what that tells me when I'm looking at this rational function, it says that all the x values for this function, I can have all the values, all the x values are all the numbers except what makes the bottom 0. So if we take the bottom and we set it equal to 0, so we say x minus 3 is equal to 0. So what we're doing here is we're finding the number x that if we plug into the bottom, it will give us a 0. So we add 3 to both sides. X is equal to 3. So what this x equal 3 is telling me is that the domain is every other number not including minus 3. Because if I take x equals 3 and I plug it into my f function, I would wind up with 3 minus 3 on the bottom, which gives me 0. So this is not in the domain. So the domain then would be every number except that one. So we start with the smallest value, which is negative infinity, and then it goes up to 3, and we don't want to include 3, because if we include 3, that would give us a 0. Union, or and, then we pick right back up at 3, and we go to the largest value, which is infinity. All right, let's look at one more. B. Let's say we have the function g, and that's equal to x divided by x squared minus 16. Give this one a try. Pause the video. So same thing here. We have a rational function, which means we have a numerator and denominator where there's a variable in both. And not necessarily, you don't have to have a variable in the top, as long as the variable's in the denominator. So the only way this function is undefined is if the bottom, the denominator, equals 0. So let's set it equal to 0 and see what x values give us 0 on the bottom. So we say x squared minus 16 is 0. Add 16 to both sides. And then, to get rid of a square, we need to square root both sides. So on the left side, I'm left with x, and then that's equal to, the square root of 16 is 4. All right? But what is wrong with that answer? Anytime we introduce a square root, we have to account for the plus and the minus. All right? The reason we have to do that is because if we plug 4 in here for x, we get 4 squared, which is 16. But same thing, if we plug in negative 4, that's negative 4 times negative 4, which is also 16. So hopefully that's kind of a helpful way to remember that. So now, what is this telling me about x equals 4 and negative 4? That's telling me that the domain is every number except these two. So we need to write it similar to the other problem. So we say domain, start with the smallest value, negative infinity, comma, then up to the next value, which is -4. And we don't include it. Union, and we pick back up at -4, but we don't include it. And then that's up to 4, because we got to account for the numbers in between -4 and 4. So we got -3, -2, -1, 0, and so on. Up to 4. And then we're going to have another and 4 to infinity. All right? So that is just a quick refresher on how to find the domain. And the reason I'm showing you this, if you know how to do this, finding the vertical asymptote is real simple. All right? So what I'm going to do is I'm just going to erase B. Go ahead and pause if you need to finish writing it. I want to be able to compare it to A with how I'm finding the vertical asymptote. All right? So example 2, we'll call it. And this is the easiest way to show you how to do the vertical asymptote. Find the vertical asymptotes. And there can be one or more. And here's part A. We'll say we have the same function, f over here. F of x is equal to x squared minus 8 all over x minus 3. So it starts out exactly the same way as over here when we found the domain. All right, so we set the denominator equal to 0. So just relate the two. Domain and vertical asymptote, they start the same way, that everything's worked almost the exact same way except the very last step. So you set the bottom equal to 0, solve for x equals 3. So we're at the same step here and over there. Now, over in domain, we went one step further and said, here's our domain, it's every number but this 3. Now over here in vertical asymptote, we're stopping here because this is our answer. Over in domain, we cared about all the other numbers. Here, now we're labeling what that 0 gives us, and that's called a vertical asymptote. So here, all you have to say is the VA, which vertical asymptote, that's how I'm going to write it from now on, is x equals 3. And then you can have multiple x values here, multiple vertical asymptotes. So for example, if you had part B, let's call it G, and let's do the same one we just had. X divided by x squared minus 16. Starts the same way. You set the bottom equal to 0 and solve for x. X squared is equal to 16. Then you have to square root both sides. So x is equal to, what is x equal to? Plus or minus 4. Or plus and minus 4. So this tells you that we have vertical asymptote is x equals -4 and x equals 4. So now we have two of these things. All right. So let's see what this looks like graphically, just so we got it in our head. I'm going to erase part B over here, so pause it if you need to. I'm going to attempt to graph part A, even though I have no idea what it looks like. But let's just say this is some random graph, not necessarily part A. I don't want there to be any confusion. So let's say I have a graph that does this right here. It goes like this, and then we're going to have this dotted line down like that. And then, so there is my function. We'll call this function h of x, whatever that is. All right? So this is my function in the white, here and here. And then this blue dashed line, it is dashed if you can tell. Yeah, you can. So this blue dashed line is what we call the vertical asymptote. So our domain would be everything from negative infinity up to this value, and then it'd be everything from this value to positive infinity. And then that number right in the middle that we skip when we do domain, that's this dashed line called the vertical asymptote. And what happens at the vertical asymptote is, notice that this side of the graph, it's going down further and further, and it's getting closer and closer to this vertical asymptote, but it's never going to touch it. It gets closer and closer, but it will never touch it. And the same thing on this side, it goes up and up and up, getting closer and closer to this vertical asymptote, but it's never going to touch it.